Okay, now we start with the first energy system that use for exercise, which is the creatine phosphate energy system. The most prevalent high energy phosphate in the body is ATP. We know that. But there is another high energy phosphate compound that is stored in muscles and other tissues, which is known as creatine phosphate. Okay. So creatine phosphate is a high energy phosphate that is stored in muscle. Just as with ATP, potential energy is stored within the phosphate bond of creatine phosphate, and this energy can be released when the phosphate bond is broken and the inorganic phosphate released, as I showed just now. Unlike ATP, however, this energy is not used directly to power muscle contraction. Instead, the energy released from the breakdown of creatine phosphate is used to rephosphorylate ADP to ATP. Thus, the creatine phosphate stored in muscle act as a readily accessible reservoir of energy for the reformation of ATP. It should be noted that a number of slightly different terms and abbreviations are used interchangeably for creatine phosphate, including sometimes you can find they call as phosphocreatine, sometimes they call as PC energy system. PC it means that phosphate creatine. Sometimes they call as PCR, phosphate creatine, and sometimes they call as CP. So it's just the same. So in terms of these, the purpose of this course, okay, this topic we will use the abbreviation as CRP, creatine phosphate, because creatine phosphate is a high energy phosphate compound like ATP, and this energy system is referred to by many sports nutrition and exercise physiology texts as a combined system, which is the ATP PC energy system. As has pointed out, ATP directly provides the energy for force production by muscle and is present in such limited amounts that it may provide energy for only a few seconds of very high intensity exercise. The role of this creatine phosphate, like the other two major energy systems, which are anaerobic glycolysis and oxidative phosphorylation, is to replenish ATP so that it is available for muscle relaxation and subsequent force production. Okay. In this text, the term creatine phosphate energy system is used rather than the term of ATP PC energy system. Creatine is actually consumed in the diet, we know that, and also it can be synthesized in the body from amino acid. And as we know that creatine is actually an amine, a nitrogen containing compound that's similar to a protein that constructed from the amino acid arginine, glycine, and methionine. It can be either consumed in the diet, via food or supplements, or it can be also produced by the body. The major food sources of creatine are beef and also fish. And those who eat beef and fish consume approximately 1 to 2 grams of creatine daily, whereas non-meat and non-fish eaters consume a negligible amount. Creatine can also be consumed as a dietary supplement. Usually, sports people take 3 to 5 grams per day. Creatine as supplement generally is found as creatine monohydrate in a white powder form, which is mixed with water for consumption. Even if creatine is not consumed directly in the diet, the liver and kidneys actually in our body can synthesize it in adequate amount if the amino acid arginine, glycine and methionine are present in sufficient quantities. That is, protein intake is adequate. And a creatine deficiency in humans would be actually extremely rare. Okay. So whether we consumed or produced by the body, creatinine is transported in the body, transported in the blood to tissue throughout the body. Tissues such as skeletal muscles will take up creatinine from the blood and store it approximately 1/3 as creatinine and 2/3 as creatinine phosphate. Okay, so this is the creatinine metabolism. So, as again, whether we consume or creatinine consumed or produced by the body, the creatine is transported in the blood tissue, okay, throughout the body. Tissues such as skeletal muscles will take up creatine from the blood and store it approximately 1/3 as creatine and 2/3 as creatine phosphate. Excessive creatine is splitted by the kidneys and is excreted as the chemical compound creatinine. The body's turnover of creatine is approximately 2 grams per day. There is an average non-vegetarian who doesn't use creatinine supplement will consume and or synthesize approximately 2 grams of creatinine daily, and the body will excrete approximately the same amount of creatinine. Since the dietary intake of creatinine by a vegetarian is nil or what we call at zero, the amount of creatinine in a vegetarian body is depend on how much the body can make. Although research is limited in this area, there is some consistent evidence that the total amount of creatinine in the muscles of vegetarians is lower than for the non-vegetarians. Vegetarians are not creatine deficient. They may have been on the lower end of the normal range, but they do have relatively less creatinine than non-vegetarians who complement the production of creatinine in the body with creatinine that found in meat and fish. Because creatinine is an important energy source, particularly for higher intensity exercise, strength athletes and vegetarians have attempted to manipulate the intake of creatinine through supplementation. And creatinine loading and supplementation kita akan discuss nanti in the supplements topic. Okay. Okay. When we look at in terms of the creatine phosphate energy systems, phosphorylase ADP to ATP, the creatine phosphate is broken down, releasing energy, and also inorganic phosphate, which is then used to phosphorylate ADP to ATP. This is a very rapid, what we call as a one-step chemical reaction that catalyzed by the enzyme we know as a creatine kinase. Okay. And if ATP concentration in a muscle cell starts to decline, the drop in ATP and the concomitant rise in ADP in cells result in an increase in the activity of creatine kinase, allowing the reactions to proceed even faster. The reaction does not depend upon the presence of oxygen. So, this energy system is considered to be one of the what we call as an aerobic energy systems ataupun without oxygen energy system. Each molecule of creatine phosphate can rephosphorylate one molecule of ADP to ATP. So the ratio of ATP energy produced is 1 to 1. Because of the speed with each of the creatine phase can act to replenish ATP, it is the preferred energy systems during very high intensity exercise when ATP is utilized very rapidly. As with ATP, creatine phosphate is stored in finite amounts in the muscles, but unlike ATP, creatine phosphate can be used to the extent that it will decrease to very low concentration. And we can look at the term what we call as depletion is used even though the muscle's creatine levels do not actually drop to zero. Secara kita kata when we look at this, so what types of activities or exercise or sports that meet this description? So it must be short, it must be fast sprint, such as 100-meter sprint in track or the 40-yard sprint in football, or short, powerful bursts of activities such as the short putt, or also jumping to the dunk of basketball, or sometimes activity that require large amount of force, such as heavy weightlifting, as I showed in the slides, the first one just now. For example, maximal effort bench press or maximal Olympic lift, such as clean and jerk. So in summary, we can say that the characteristic of the creatinine phosphate and systems are: number one, it has a one chemical steps. Okay. Number two, it catalyzed by creatinine kinase. Number three, this is very fast reaction. Number four, one molecule of creatinine phosphate can rephosphorylate one molecule of ADP to ATP. So maknanya 1 ATP per creatinine phosphate molecule, 1:1 ratio. It has a 5 to 10 seconds for creatine phosphate muscle to be depleted, the duration. It is anaerobic. These energy systems do not use energy. Okay. And fatigue associated with creatinine phosphate depletion, and also the predominant energy systems in very high intensity, short duration exercise when ATP is being used very rapidly. So selalunya dia akan guna dalam power events. As I mentioned just now, dalam short and fast sprint, short putt, dunking a basketball or very heavy weightlifting.